welcome our next speaker, Oscar Celma. Oscar is a head of AI at Pandora, and he will be talking about humans and AI working together to curate personalized music recommendations. Please welcome Oscar to the stage.
Hi, welcome everyone. I'm really happy to be here, all the way from San Francisco. So today I want to present you a few lessons learned building a large music recommender system. Before, let me give you like a couple of minutes of what's Pandora. Pandora is a music streaming service. It's the largest one in the US. We're trying to help not only the listeners playing the best personalized music experience for them, but also in many ways we also help the artists and the content creators, as well as we have the biggest audio advertising marketplace. So yeah, Pandora is really big in the USA again. People on Pandora and the mobile app spend more time using Pandora than other very well-known mobile applications. People spend like over 1 day with us per month, and we're very well connected with, we're very well embedded with connected devices and with a lot of cars. So you can play Pandora anywhere you want to. And it's like full on-demand premium service. As I said, that's the last slide that I'm bragging, and then I'll go into like the actual content. So yeah, Pandora, compared to other music services in the US, it's the largest one, and we're really proud of that. So now into the main content of the presentation. So I want to share a few lessons learned about building a large music recommender system. So I'll start like few learnings from gathering the data, into the training the model, evaluating the model, and then putting this model into production for like millions of people. So the first lesson learned that I'll go into details is implicit user signals are more useful than explicit user preferences. What I mean by that is like when you're getting data, let's say that if you ask me, hey Oscar, what are your favorite artists? And actually that's true, I would go like, no, I love Johann Sebastian Bach, Chet Baker is really cool, Paco de Lucia, the best guitar player ever. I also been listening to you too since I was a child. That's, if you ask me, that's my explicit preferences, but then if you go into like the music service and start like tracking, because you need to track everything that you do. You're tracking my plays, what I like, what I don't like, when I listen to Pandora, which device I use. You surface all this information, and then you see that I'm more into Foo Fighters and AC/DC, which is fine, but it's not like the same as I consider myself. So on the one hand, we have like, hey, you think you're cooler than you actually are based on like how you react and how you use the system. So it's kind of an imposter syndrome here. So that's the first one. And the main takeaway here is like implicit signals that the application use is far more useful than your explicit preferences. And that's kind of a misalignment between how you think you are, what are your preferences, and what actually the system knows about you. So that's the first one. The second lessons learned that I want to share with you is like, there's so many models you can choose, from deep learning to logistic regression. There's many ways for you to choose a model. One of the main takeaways for me is like, do not always choose the most accurate model. So there's some trade-off between when choosing a model, it's not only choosing the most accurate one, but there's a lot of things like moving this thing into production, how easy it is to put this thing into production, does it scale? So I want to focus now on one trade-off here. One that I think is very important, it's the trade-off between being able to explain and interpret your model versus how accurate this model is. So on the one hand, we have like simple linear regression or decision trees that are more or less easy to understand why you recommend this song for me or how you make this prediction, because the model is understandable. But their accuracy is not as good as others, such as deep learning. So on the other hand, we have deep learning, which is, well known, that has a way higher accuracy, but it's a black box. So in case anything goes wrong, it's more difficult to debug or to understand why something failed there. At Pandora, we use a in between solution. We use an ensemble recommender. We have over 70 algorithms that we deploy, and then we have an ensemble recommender that combines all these 70 algorithms using a technique called exploit explore, so we can balance familiar music that you know about and also play some music that you've never heard before that we think you might like. So that's the second main takeaway. Do not take into account only accuracy, but there's a lot of trade-off when selecting the model that you want to build, the recommender system you want to build. So the third lesson, I think is very important. So we have the data, implicit data. We're grabbing all the information from all the users. Now you have your model that you train. Now it's like, what should this model be optimizing for? Should we, based on root mean square error or the area under the curve, or what should we be optimizing for? One of the main takeaways here is you should be optimizing for something that correlates or it's linked with a business metric that's important. So let me go a little bit into details here. When I talk with my boss, big boss at Pandora, I'm like, he's asking me, hey, Oscar, we need people to spend more time on the app. We need more monthly active users. We need to increase the user lifetime value. We need to make more money. And then when I talk with my team, my ML team, they're like, well, no, we're focusing on the accuracy of the recommendations. It should be perfect. We balance the quality, novelty, familiarity. So there's kind of a misalignment between what's actually measurable and expectations of high-level business metrics. So for this, we found kind of a in-between solution where the goal is to try to measure a metric that's a proxy for high-level business goals. So I will go more into details here. We do a lot of evaluation. We evaluate everything. There's two types of evaluation. The first one is offline evaluation. By offline, I mean we have so much historical data. We have 95 billion sums. That's 95 and 9 zeros. It's a large number here. Billions of stations created. Every day, we get 1 billion data points but from the users, based on the skips. I play this song. I create this playlist. I send you an email from marketing. I click there. So we have so many implicit data as well here that we can just build models based off of the offline historical information and kind of measure the accuracy or the error based on this only offline information. So the measure that, or the metric we want to measure and we want to optimize or maximize here is the probability that you will thumb up or enjoy that song for you. So this kind of metric is a proxy for satisfaction, and we believe satisfaction will lead to more engagement and being happy about the experience you have at Pandora. So on the one hand, the offline evaluation, we try to maximize probability that you will thumb up or like a song. Either you like it before or it's a new song that you never heard but we think you might like. So on the other hand, now that we have the offline evaluation and it's all good, your model predicts very good accuracy, we know the songs that you might like, now we need to test that into the wild. We need to test with the users and check if the users like this new algorithm, this new way to play music at Pandora or not. So for that, we do online evaluation, A/B testing, have a group of a group of users that are on a treatment group, and then a control, and you want to check if there's any statistical significance difference between one group and the other. So for this, we measure everything, but the first thing we measure is the activity. Are people thumbing more? Or are they skipping less? Are people when you send a marketing campaign or when you send when you play an audio ad, are they clicking through this audio ad and buying something? So all this activity is more a short term. We see changes in our A/B testing. After a few days, weeks, we can see some changes there. Actually, if there's a bug and we just learn something that's wrong, in 2 hours, we'll see the metrics are going crazy and we know that something wrong happened there because people start reacting. But we also, and that's where I'm getting closer to what my boss wants from me, we can also measure on online A/B testing. We can also measure time spent. Are your sessions longer when you start Pandora? Are you spending more time than before? Are you coming back to Pandora active days more often? You used to listen to Pandora once a week. Now you're coming 2 or 3 times a week. So we can also measure retention. And these metrics takes actually months or even years. It takes a lot to see if there's any changes in this A/B testing or control experiment. And actually, we have experiments that we run for 6, 9, even 12 months, and that's where you can actually see if there's been any win in terms of long-term retention. So one important takeaway here, and try to close the gap on this evaluation, is that we're measuring on the offline, we're trying to maximize satisfaction, we're trying to maximize engagement. So what we've seen is like, if there's any movement on like the short-term metrics on the online experiment, if people on the treatment group start to like more the music, start to interact more and engage with the app, that correlates. I don't mean there's a causation here, but like it correlates. There's some correlation there with like these people are more likely to stay longer and be more engaged and like using Pandora more. So that's the third learning here about you need to evaluate something that your boss cares about, and in a way that you have a proxy that you can measure that correlates or has some meaningful link with the business metrics. The fourth lesson learned is that your experimentation environment or your experimentation models should be the same as when you're moving stuff into production. What I mean here is like you have a data science team, you don't want them to be in a corner writing very cool stuff in R or Python or like nice models, but then once you need to move that and scale to 75 million people, you need like, to throw all this away and have engineers to rebuild it. That's very ineffective. So actually at Pandora, what we have the same kind of tools or pipeline for both the environment of development, but also like production. So all the stuff we do when we're testing our work, it follows the same kind of pipeline than the production one. So we use we're really happy with Spark and Scala, and we use a lot, Redis and Memcache and a lot of stuff into the online recommender system. But what's very important is like you have your model. Ideally, you build a model where both experimenting with it, offline testing, and moving into the online and scale to all the users is the same code. Production system is the same as your experimental environment. But your model needs to be recomputed and needs to be rebuilt every now and then. At Pandora, we just recompute all the models every night. Recall that we have 1 billion data points per day, so by the end of the day, we just like recompute everything and try to be better. So when you're recomputing a model, and you're deciding, is this model good enough? Is it better than the model I have from yesterday? You need to take into account a few things, and especially you need to watch out for some potential issues. So if you recompute your model from last night and you're deciding to put it into production today, you need to compare with the actual production model and see, like, is it as good as what we have up and running now? So you need to check on the offline evaluation if there's any large delta error, if like your current model is as accurate as the one that is currently running. Ideally, you also want to have both models onto the A/B testing, so you have both models running at the same time. Some users are using the current one, and some users the more recent one, and you want to check that there's no like statistical difference in like any of the metrics there. There's some big catalog changes there, like if we license 1 million songs, you'll put this into your model representation, like you put everything into some embedded space, and this probably will change a lot of things, so you want to make sure that if there's like a lot of items to be recommended, that this does not affect the quality of the model. And last but not least, the UI changes, the UX, product people add more signals. There's like now you can replay a song, now you can download stuff, you can play music offline. All this might affect your model as well. So the fifth lesson learned here is like, I think it's very important to add domain expertise in your machine learning team. What I mean here is that we think humans in the AI loop are very important. I hired astrophysics, physics, like pure math, computer scientists, all PhDs, but I think it's great that some of them are passionate about music or other domains, if you're into books or movies or whatever. Like, I think it's good that you have some people that really care about that domain. So actually, I think music is very special, as it's other domains. Music has a high emotional connection with all of us, as you can see in the picture. Music is also very special because it's consumed in like, songs are like a few minutes long, 4 minutes, 2 minutes if you like Ramones. But the main thing here is like, you can recommend a song, and the time invested to listen to this song is like minutes compared to like Netflix or Amazon or other more complex domains in the sense that, if Netflix recommends me a TV show or a movie, I need to invest more time. So in this case, we have like probably an advantage of like, we can just try out things faster, and it just takes minutes or seconds to sum it up or down, and we can get a lot of feedback. Songs are consumed like over and over. People that like One Direction listen to these songs over and over, like my son. People like to rediscover songs. Some music that you used to listen to 10 years ago, now you listen to again, and it brings you back memories from back then. Also, music has this kind of lean back versus lean in consumption, like, hey, Pandora, play some music that I like and just run it, or more lean in, I want to create a playlist, can you help me, which songs should I add on this playlist? So these modes are different when the recommender system needs to be aware of that. And finally, there's music for dinner, music for working out, music for Sunday brunch. So all this context is very, very specific. So with all that said, I think you need domain expertise, you need people that care about music or in any other domain that your recommender system is based on. So one thing that I said to the data scientists, like, you're the expert here, so one of your main goals is to teach the model to not do stupid things. In the end, we need to remind ourselves that the machine has no common sense. It might be an expert, maybe very good at deep learning and at finding correlations between things, finding vector similarities, but in the end, has no common sense. So just to finish that, here's an example of a song, and we'll see like what could happen with this song. Supposed to be distorted because of AC/DC. So what happened here is that you don't want to play this song in a Christian contemporary hard rock station, and that actually happened to us. So you need expertise there to make sure that there's a lot of restrictions. That any domain is very complex, and you need people that really care and apply common sense there. So just to summarize, probably you're not as cool as you think you are. That's number one. Number two, deep learning is cool, but there's a lot of logistic regression or random forest might work very well as well. Number three, try to optimize for something that the business cares. Number four, try to not reinvent the wheel, try to not re-implement everything. And number five, do not play AC/DC Highway to Hell to this contemporary Christian station. Okay, thank you very much.
Thank you, Oscar. That was a great presentation. I love getting my recommendations on Pandora, and it's finally great to see the behind-the-scenes scoops. I had a question, though. The music I love depends on the time of day, activity, and all that, and you had a bullet over there on the context. Yep. Could you tell us a bit more on sort of how you model for the different contexts and how you predict?
Yeah, of course. I mean, we have all the information. When you listen to some music in the morning, we know everything about you in terms of what music you like. So we, of course, can build models that take into account. Actually, there's some context, like there's contextual multi-arm bandits. There's some tools there that allow you to make sure that recommendations in the morning are different than in the afternoon or in the evening. So we track everything, and then we make sure that based on these kind of subsets of who are you on Monday morning or like Friday night, we can recommend that music for that particular day. We also create a lot of playlists, and because we also have an on-demand system now, on-demand service, we can create personalized soundtracks. Like we can create a playlist for you that's special for Friday night or for Sunday morning. So yeah, we take that into account a lot, yeah.
Great. I would love to open up for some questions.
Hello. Do you use emotional tagging from people, like a feedback loop from people where they tell which emotions they feel when they listen to the song so that you can recommend it to other people that would like to feel the similar emotions or plan to do so or try to do so?
Yeah, we don't actually get the emotional information from the users. What we do is, so Pandora is well known for the Music Genome Project. So we actually have humans and machines that listen to all the songs in the world. So for each song, we know which mood is this song. Is this song like a sad song, angry, or exciting? We tag each song with a particular list of moods. the probability of each mood. So with this information that's, again, curated by humans and expanded to the whole millions of songs by machine listening, we're able to know like the mood of the song. And then based on that, we can extrapolate if you're commuting, if you're working out, like depending on your contextual situation, we should be able to play songs for that context that fits a particular mood. Yeah, thank you.
Any more questions? Yeah, I see a hand over here. If you could give your name and the organization and then the question, please.
Hi, Ron from Science Labs. There is a point in your presentation that you said that the user might think he's cooler than what he thinks. Do you think that you can, or do you planning on like trying to shape his taste in music, or you want him to help him to find out what he like in a way?
Yeah.
Because it's a delicate border.
Yeah, that's a really good question. I mean, so Pandora is well known for being like a kind of a personalized radio, internet personalized radio. So there we had all the power to decide, when you start a YouTube station, you can try to play like songs that you like, songs that you might like. So we have a lot of a space there to what we call explore versus exploit, play novel music for you versus familiarity. So we have some word there. We have some space there to try new things. But it's true that once we had 2 years ago the on-demand service where people create playlists, there you can explicitly tell us what you like. You create your own playlist. So the main takeaway is like Pandora is not the arbiter of cool. We don't want to change anyone's kind of music taste. But it's true that Pandora is also well known for music discovery. So we offer a lot of options for you. If you're more like in lean-in mode and you're open to like discover music, actually our main algorithm is based on this concept of explore versus exploit. And if we know that you're into like, in a particular context, you're more into like discover music, we can kind of boost the explore algorithms and play music that you haven't heard before. But it's not our goal to change anyone's taste.
I'm afraid we don't have time for any more questions. I hope you can find each other after the session. Well, thank you very much. It was great to have you here.
Thanks.